we are going to have some important numericals from +1 physics unit 1 named as physical world and measurement. First example, find the dimensions of charge, potential, resistance and capacitance. These three you have already learnt in your 10th class. This you will be learning in your +2 class. First we have charge. Now formula of current is equal to charge upon time, that is I is equal to Q upon T. Rearranging Q comes out to be I into T. Therefore the dimensions of charge becomes I into capital T. Second, potential. Potential is equal to work upon charge. Now potential is denoted by V. The dimensions of work are ml square T minus 2. Upon charge we have already discussed, I into T. Finally potential becomes V equal to m L square I minus 1 T minus 3. Resistance. From Ohm's law, V is equal to IR. Rearranging R comes out to be V upon I, or R equal to V. Just now we have calculated ml square I minus 1 T minus 3 upon I. So finally R becomes m L square I minus 2 T minus 3. Capacitance. Capacitance, it is the capacity of a condenser to hold charge, which is given by charge upon potential. Now capacitance is denoted by C, charge by Q, potential by V, or C is equal to Q upon V. C is equal to charge we have calculated over here, I into T, upon V we have calculated over here. So dimensions of C comes out to be m minus 1 L minus 2 I square T plus 4. Next example we have, find the physical quantities with the dimensional formula. Now we are given dimensional formula for different physical quantities and we have to identify those. दोस्तों इनमें सबसे पहले हम फोर्स के डिमेंशंस जो कि होते हैं एम एल टी माइनस 2 उसको फाइंड आउट करते हैं या फिर बनाने की कोशिश करते हैं टू मेक द फॉर्मूला और आइडेंटिफाइंग द फिजिकल क्वांटिटी सिंपलर. द गिवन इज एम एल स्क्वायर टी माइनस 2. रीअरेंजिंग, नाउ वी हैव रिटन एम एल टी माइनस 2 बिकॉज ऑलरेडी टोल्ड फोर्स इनटू एल. Now this becomes force into L, distance, force into distance. Now force into distance you have already studied in 9th, which is work. Next, m L square T minus 3. Rearranging, this becomes m L square T minus 2 into T minus 1, or this can be written as m L square T minus 2. This will be taken to the denominator side and it becomes from minus 1 to plus 1. Now this becomes work because ml square T minus 2 represents our work. So it is work upon time. Now in your 9th also you have studied work upon time is power. Next, m T minus 2. Now multiplying and dividing by L. Multiplying and dividing by L we get m L T minus 2 upon L. Now this becomes force upon length. So force upon length is a physical quantity known by surface tension. This you will be studying in +1 unit 7. Lastly we have m L minus 1 T minus 2. Multiplying and dividing by L square, that is area, we get m L minus 1 T minus 2 into L square upon L square, or we get m now 2 minus 1 plus 1 T minus 2 upon L square. So this becomes force upon area. Now force upon area is a pressure. You have learnt in your 8th standard also. Next example is from the conversion of one system of units into another. For example, the value of capital G, universal gravitation constant, in CGS system is 6.67 into 10 raised to power minus 8 dyne centimeter square per gram square. Now calculate its value in SI unit. Simply we have to convert CGS system into SI system. Now from Newton's law of gravitation, F is equal to G m1 m2 by r square. Already learnt in your 9th standard. Rearranging, G comes out to be F r square upon m1 m2. Now dimensions of force are m l t minus 2, distance L square upon m into m. So finally we are left with m minus 1 L cube t minus 2. Comparing it with the general formula m raised to power a, L raised to power b, t raised to power c, the value of a, b and c comes out to be minus 1, 3, minus 2 respectively. Now it is clearly indicated over here. That means we have to convert CGS into SI. So first we will write CGS and on the second hand we will write SI. In CGS, N1 is given to us. This is the N1 value. M1 1 gram, L1 1 centimeter, T1 1 second, N2 we have to calculate. M2 we know 1 kg which is 1000 gram, L2 1 meter which is 100 centimeter, T2 again 1 second. Formula. This we have already discussed in uses of dimensional equations. N2 is equal to N1 M1 by M2 whole raised to power A, L1 by L2 whole raised to power B, T1 by T2 whole raised to power C. This is the formula used over here. Substituting the values, N2 is equal to N1 is given to us. Now M1 by M2 it becomes 1 by 1000. ग्राम से ग्राम कैंसिल आउट हो जाएगा. सिमिलरली L1 by L2 इट बिकम्स 1 upon 100. सेंटीमीटर से सेंटीमीटर कैंसिल आउट हो जाएगा. सेकेंड से सेकेंड कैंसिल आउट हो गया. वी आर लेफ्ट विद 1 raised to power minus 2 it will again come out to be 1. So finally we are left with N1 into this becomes a positive 1000 into 10 raised to power minus 6. So finally we are left with N2 is equal to 6.67 into 10 raised to power minus 11. So in SI units, G is equal to, we have calculated 6.67 into 10 raised to power minus 11 and the units are Newton meter square per kg square. Next example we have, check the correctness of the following equation by dimensions. S equal to ut plus half at square. Left hand side is S. S denotes distance. So distance is equal to L. Right hand side, first term is ut. Initial velocity into t time. So velocity has the dimensions Lt minus 1 into time t. So it remains L. Second term is half at square. Half is dimensionless, a acceleration t time square. Acceleration having dimensions Lt minus 2 into t square. So again we are left with L only. So right hand side becomes first term plus second term. L plus L twice of L. Since 2 is again dimensionless, so by principle of homogeneity, left hand side dimensions are equal to right hand side dimensions, each being equal to L. Therefore the given equation is dimensionally correct. Next we have, check the correctness of Fs equal to half mv square minus half mu square. This you have learnt in your 9th work energy theorem. Now left hand side is Fs. F force, S distance. So force having the dimensions m L t minus 2 into distance having dimensions L. So we are left with m L square t minus 2. Right hand side, first term is half mv square. Half is dimensionless, m mass velocity square. So we are having dimensions m L t minus 1 square. Finally it becomes m L square t minus 2. Second term half mu square, half is dimensionless, m mass into velocity square. Again we get the same dimensions m L square t minus 2. So since the dimensions of all the terms are same, hence the given equation is dimensionally correct.